RC Circuits 1, Capacitors in Series. RC circuit is an electric circuit composed of resistors and capacitors driven by voltage. To give an example of a simple RC circuit, I'm going to draw a schematic diagram. So I have my resistor, I have my battery, and then finally I have my capacitor formed by two metal plates. Now remember, batteries always form, or the current always flows from the short line to the long line, so current will always flow in this direction. And that means that it's flowing from positive to negative. Now as it's flowing from positive or negative, charge is going to build up on the capacitor. So a negative charge will build on the plate below, and a positive charge will form on the plate above. Now, what is an RC circuit used for? One of the uses is for blocking or filtering certain frequencies. Okay, filtering certain frequencies. That's one use. Another use is that RC circuits can be used as almost like timers. Okay, to give you an example, this RC circuit always goes through a series of steps. Okay, a sequence of steps. The first step is that the capacitor charges. The second step is that the capacitor then discharges through the resistor. And then after it's discharged through the resistor, the voltage in the capacitor decreases to a certain level. Okay, so once voltage decreases, it can trigger a signal. So it triggers a signal. So for example, let's say I have windshield wipers. So windshield wipers are timed using RC circuits. The capacitor charges, it then discharges, and then once the voltage reaches a certain level, it triggers a signal, and that would be the windshield actually turning. And then the cycle basically repeats. It charges again, discharges, and then the voltage decrease, triggering another signal. So that's basically how RC signals work and what they're basically used for. Now let's go through the actual equations that we'll need to know for RC circuits. So the first equation is determining the equivalent capacitance in a series circuit. So let me draw a quick example. Here's the example here. So let's say I have two capacitors. Okay, so not only do I have one, I have a second capacitor. Okay, I have two capacitors up top formed through the battery again. Okay, now that I have two capacitors, I can use this equation here to determine the equivalent capacitance. Okay, so this is equivalent capacitance. So equivalent capacitance would be if I were to somehow combine these two capacitors into one capacitor, what would be the capacitance of this combined capacitor instead of having two? Okay, and then same rules are going to apply because it's a series circuit. The total voltage is going to be the sum of the voltages. And then here's the difference. The total charge is going to equal the charge of each capacitor. Okay, so the total charge is going to equal the charge of the first capacitor, and that's going to equal the charge of the second capacitor.